Hello students. In my last video we understood about the direction of current given by Lenz. We call it as Lenz law. Right? Now let us see whether the law of conservation of energy holds in Lenz law or not. For that, first let us assume that the north pole of a bar magnet is approaching the coil. Right? Case 1. Case 1 what? Here bar magnet with its north pole moving towards coil. Moving towards the coil. So what happens? As bar magnet comes closer and closer to the coil, the flux starts linking with the coil. And as it comes closer and closer to the coil, the flux linkage increases. The first point, we have to move bar magnet towards the coil. Moving the bar magnet towards the coil means you have to do some work must be done to move bar magnet towards coil. Moving the bar magnet means nothing but you are doing certain work. Right? Moving the bar magnet means nothing but you are doing certain work. Right? Now next, this work done imparts kinetic energy to bar magnet. Right? Work done means nothing but stored as kinetic energy. It is imparting kinetic energy to the bar magnet. So bar magnet, now what happens? The bar magnet moves closer and closer to the coil. Okay? Due to this, what happens? The flux linkage with the coil increases. Right? Now, when flux linkage increases, what happens? Induced EMF is generated in the coil. Right? Now, induced EMF means nothing but an induced current is associated with it. So, I can say induced current is established in the coil. Right? Induced current is established in the coil. Now, see, first what we did, we are moving the bar magnet. Means to move the bar magnet, you are doing certain work. Means you are applying mechanical energy. Right? Now, at last, what happened? It has converted into electrical energy. I can say this is electrical energy. Means mechanical energy has converted into electrical energy. Okay? Converted into electrical energy. Means what? Energy from one form has changed into another form. This is nothing but law of conservation of energy. One form of energy transfers into another form of energy. Now next what happens? Kinetic energy, it is converted into electrical energy means kinetic energy starts decreasing. Kinetic energy is decreasing means what? Nothing but the coil is repelling the bar magnet. Coil is repelling the bar magnet. Why it is repelling the bar magnet? Because here the coil has converted into the north pole, because here the direction of induced current is in anti-clockwise direction. Right? Now here as this mechanical energy, after converting into electrical energy, kinetic energy is decreasing. So only it is converted into electrical energy. No, mechanical energy is changing or taking the form of electrical energy. Here coil starts repelling the bar magnet because coil has converted into north pole, as the direction of induced current is in anti-clockwise direction. Okay. Now here, when bar magnet is moving towards the coil, 100% law of conservation of energy is valid. Now next, let us see case 2. When bar magnet moves away from coil, whether it happens or not. First, even to move the bar magnet away from the coil, work done to move bar magnet away from coil, you have to do certain work. So this imparts kinetic energy to bar magnet. So now as bar magnet is moving away from the coil, flux linkage with coil starts decreasing. Alright. Now what happens again? Induced EMF is formed. Means nothing but induced current is formed. Here also you will find induced current has formed. Means here work done means mechanical energy again converted into electrical energy. Means one form of energy is transferred to another form of energy, which is nothing but law of conservation of energy. Alright. So next what happens? Kinetic energy decreases. Means here coil starts attracting the bar magnet. Attracting means coil has converted into south pole. Coil has converted into south pole means the direction of current has changed into clockwise direction. Direction of current has changed into clockwise direction. So when you push bar magnet away from the coil also, the mechanical energy is converted into electrical energy. Okay. Now next, okay, from this explanation we understood that 100% this Lenz law follows the law of conservation of energy. Now let us think in another way. How means? Let us suppose that bar magnet as usual with north pole is approaching towards the coil. Okay. Now let us assume that current is moving in a clockwise direction. Here we said anti-clockwise, no, when it is moving towards the coil. But instead of anti-clockwise, let us think it is moving, current is in clockwise direction. Current is clockwise direction means coil acts as south pole. So now what happens? There will be force of attraction between the north and south poles. South pole of coil and north pole of bar magnet. Now when force of attraction is present, what happens? Kinetic energy goes on increasing. Means kinetic energy is not changing its form. It just goes on increasing. And it is the violation against law of conservation of energy. Law of conservation of energy. So this explanation that when the bar magnet is moving towards the coil, current will flow in anti-clockwise direction and makes the coil as north pole and repels the coil. And when bar magnet is moving away from the coil, current flows in clockwise direction and attracts the bar magnet. Is the correct explanation, because it is happening. Means here the current direction is clockwise and here the current direction will be anti-clockwise. So from this we can say that Lenz law proves the law of conservation of energy holds good in this concept. Thank you for watching my video. Yours, Reshma Physics.